sides of the equation. Does that sound familiar to you?
Yes.
Perfect. So the right side becomes positive 11. And the last thing you want to do here is like try to square. You want to undo the square at this step. And you do that with the square root. So you're going to take a square root of both sides. And what would be ideal, what would be really ideal is if the square root of 11 was known, but it's not known, it's not friendly. So unfortunately, you have to leave it as this plus or minus square root of 11. Okay, but it does undo the square on the other side. And then from here, you subtract 4 and on both sides. And I recommend putting it in front of the plus or minus. So you get minus 4 plus or minus the square root of 11. And it's two solutions. Sometimes they want you to write them out separately. I don't know why that's so important, but they're this is more compact, but I think sometimes they want what's on the right here for you to do.
Yeah.
Any questions on that?
No, I think that's good.
Okay, so we'll do 30. We'll just look at it together. It's really no different. Same set of steps. You start by moving that constant term to the other side. This time we're going to add though instead of subtract. H squared minus 10h equals 4. And then this is really key. You have to put that placeholder, that bucket or whatever, line or just whatever you want to do to make sure it's in both places. And then in terms of what goes down inside parentheses, it's half of negative 10 because that operator goes with the number. So it'd be h minus 5. And then plus 25 there.
Yep. That's what I got.
So what is the next step at this point? What's the next thing to do to solve this?
You square both of them.
Square root both sides, yeah. And when you square it to right, it's plus or minus. Plus or minus. Very important that you get both of them in there.
And then you add 5 to both sides.
Yes. So you get 5 plus or minus the square root of 29.
Yeah.
Okay, so why don't you try 31 on your own? Give you, a couple minutes here, and let's see what you come up with. It does work out. It's not a perfect square or anything, but it's not any different than the ones we just did. Yeah. So why don't you give that a try and let me know what you come up with.
Okay. Okay, I got t equals 6 plus or minus square root of 26.
That looks right. Let me just write this down here. T squared minus 12t equals negative 10. So you get t minus 6 squared plus 36 equals 26. Yeah, that's awesome. Okay. Let's hope you get some like that on the test because those aren't too difficult. I know your test is probably, you said something about it being next week. You definitely want to review this, completing the square before then, because it's something you'll forget unless you do it every day.
Exactly. That's why I think I scheduled another session on Sunday because I think I'm going to take my test Monday. So that'll
perfect.
Be
yeah, we'll definitely do some more then. So the next one here, it says to identify the discriminant for each quadratic and describe the number and type of solutions each equation has. So let me actually snip that part in for the notes part of this because it'll help. You might have some of your notes already. So the quadratic formula, I'm going to write that out here, plus or minus the square root of b squared minus 4ac all over 2a. Do you remember which part is the discriminant? It's okay if you don't. I'm just asking. I'm not giving it to you. It's the part under the square root.
Oh, yes. Yeah.
Okay, but it's not the square root. It's the part under the square root. It's very important. There's a distinction. It's a small one. May not matter to you right now, but it's just the part under the square root. So if, and there's three cases, if d is greater than 0, okay, there are two real solutions. So see where it says the word describe?
Mm-hmm.
That's real or complex or imaginary, depending on your instructor. The number, that's where you have to say 2. So your instructor expects to see both like the number and then a real or imaginary solution. So if d is equal to 0, there is one real solution.
Yeah.
And if d is less than 0, there are two complex solutions or roots. So in math, we use all of these things kind of interchangeably: roots, solutions, answers. You have to know this though. And I don't have a good way to tell you to remember it, unfortunately. See TikTok or see, or just spend a few moments to try to, get that down. But and the nice thing is they're not actually asking you to solve it. Like it does not say it does not say to solve this. It just says determine the discriminant. Okay. It means calculate this b squared minus 4ac and then write out one of these three options. Okay, so this is ax squared plus bx plus c, and the a and the b and the c are the coefficients, but it does take on the sign, the operator. So all you've got to do here is calculate b squared minus 4ac.
Yeah.
Okay, so we got minus 13 squared, that's 169, minus 48. So that is, well, it doesn't actually matter what it is. It just matters that it's greater than 0. I know as a student you want to calculate it, but you only care that it's greater than 0. So your instructor wants to see this calculation, then they want to see two real solutions. And if you do all that, you'll get, full credit on the problem.
Yeah.
All right, so for number 33, the thing that we talked about last time is when you're solving a quadratic, you always want to bring this constant term to the other side of the equation. The exception is, of course, when you're completing the square. Math is full of exceptions. So this is 3x squared minus 2x plus 6 equals 0. So I'd like you to calculate b squared minus 4ac from this.
Okay. So, it would be, so A would be 3, B would be -2, and C would be 6, right?
Perfect. Yeah. Perfect.
Okay, and then you do -2 squared.
Okay, it's very important that you put it in parentheses.
Yeah. And then -4, parentheses 3 and 6. So then it would be 4 minus 122, I think it is.
You got a little too big there, but it actually doesn't matter because the number is so much bigger than 4. But do you know if you're allowed to use a calculator on this test?
Oh yeah, we are.
Okay, if you need to, go ahead and grab it. I like having, it's like wearing your your basketball shoes when you're playing basketball. You might as well have the right stuff out.
Oh, so it's 72.
Yes. But again, like what really matters, and I know as a student, you really want to like figure this out. You just care that it's less than 0.
Yeah.
It's kind of like when you're late. It doesn't matter whether you're 1 minute late or 10 minutes late. I mean, I guess you could argue that, but like some people are like, you're either late. It doesn't matter whether you're 1 minute or 10 minutes, you're late. And that's all we're saying here. Okay. So 2 complex roots.
Yeah.
All right. And just because we've got the time here, I want to just this problem. Let me go back to question 1. Now that you've got kind of a better understanding of this discriminant stuff. So see how this has 2 real solutions in problem 1? The discriminant is greater than 0. That's what it means to have 2 real solutions. It crosses twice. And then similarly, question 2, this has a discriminant that is less than 0. Okay, because it does not cross. It has 2 complex roots. And I know we've already answered these, but it's all related. It's all consistent with one another. And then the next thing here is, see how it touches?
Yeah.
So that's your discriminant equal to 0. All right, and that's all I'll say about that.
Okay.
All right, so number 34. The instructions say to use the graph to solve the system. So when you solve a system, what you're expected is to give either an ordered pair, which I think is probably the most common answer, of the intersection. Sometimes they would prefer you to say like x equals and y equals, but that's implied by the ordered pair. What is the ordered pair where these intersect or touch in this case?
1 and 2.
1, 2, yes. And that's the only place. Let's do 36 next, and then we'll come back to 35. I would be shocked, frankly, if you got a question like this in your test. I mean, you're just literally reading off the answers. Is that something your instructor has done before? Something kind of, really trivial like this?
Yeah, a little bit. We haven't done a lot of these, so it's kind of like a weird. I don't think that particular one's going to be on our test.
Yeah, I would think you'd be more likely to have to graph it and then show the solutions after you graph it. But anyway, what are the 2 ordered pairs here for the intersections?
It would be 0, 7.
Okay.
And then -2, 2.
I think it's 6.
Maybe it is 6.
Yeah, I know it's not that easy to count.
Yeah, it is 6.
Yeah, -2, 2. Good. You have to give them both. If you give one, it's not like a choice. You have to give them both. 35, there is no intersections.
So it would just be no solution. Would you just put on?
Yep. I like that wording. No solution. That's pretty clear. It's hard to be any clearer than that. No means no in almost every language. So it seems to work out in math as well. All right, so got some final problems on this. So let's take a look at 37 next. here. Okay, so it says the instructions say to solve the system algebraically. And really the only way to solve, when you have a square, the only way to solve it is with substitution. That's really the only way. And do you notice how y has already been solved for? Are you still there, Isabel?
Oh, sorry, you kind of broke up. Say that again.
Do you see how, yeah, and is, just to be clear, is my audio okay tonight? Because a
Oh
customer was
yeah,
having issues earlier, and
it's good right now. I think the Wi-Fi kind of just got weird because it just started raining where I am right now.
yeah. So this 5 minus x, see how it's already solved for y in the second equation? That's going to go in for y.
Yeah.
You could solve it for x. You will get the same result, but you have to be comfortable substituting for either variable. Okay, now this next step is key. If you haven't foiled in a while, it's better to expand the binomial like this and write it out rather than to try to shortcut it. And you want to use FOIL on that. So you got 5 times 5 is 25, 5 times minus x minus 5x minus x times 5 is minus 5x minus x times minus x is plus x squared equals 25. And so now you want to combine like terms. And then you also want to bring everything to the left. Okay, so like, do you see how when you subtract 25 from both sides, it cancels?
Yeah.
That's nice. The x squareds combine. So you got two of them, two x squareds. And then minus 5x gives you minus 10x equals 0. Are you okay up to this step with how to work a problem like this?
Yes.
Okay. Now, the first type of factoring that you are supposed to learn and remember is greatest common factor. You use that when all terms have an x. Do all of our terms have an x in it?
Yes.
Yes. So you factor out at least an x, but you can actually factor out a number 2x from both. Can you tell me what goes inside parentheses?
It would be x and then minus 5.
Perfect. Yes. Okay. So now you set each term equal to 0. So you set 2x equal to 0, and then x minus 5 equal to 0. And you solve for x.
Yeah.
So on the first one, what would x equal?
It would be -2.
You're dividing
Or
them.
0, 0,
Yeah,
0.
0. Yeah, that's why I'm asking, because I know sometimes you get to the end of these problems, you're like, you
Right. You
almost
mix
forget.
up the equations.
Yeah, and your math teacher, if he or she cares, they really want you to get this right. They're not trying to like make it so overly complicated. But this is only half the answer though, because we need the y values. Okay,
Yeah.
and that's where you have to go back to the original equation. And since y is already solved for in the second equation, we're going to use that second equation to find y, and you want to do it for each of them. So it's like you're going to use your answers, and back here, and you're going to get two ordered pairs. So when x is 0, it's y equals 5 minus 0, which is 5. So that means your ordered pair is 0, 5. X is 0, y is 5. And then you do it again on the right when x is 5. When x is 5, you have y equals 5 minus 5, y equals 0, 5, 0. And no, they don't always work where they just flip. That would be a dangerous assumption to make.
Yeah.
Any questions on that?
No, I think I got that one.
Okay. is there a program at UT that you're UT Austin that you're thinking about for study?
I don't, well, I went in because I've always wanted to go to UT just because I used to live in Austin. So like I've always wanted to be back there. But lately, I don't know. I've been trying to think. I've been so frustrated because like I want to know what I want to do because it'll narrow it down for colleges to look at.
Of
But I
course,
just
yeah.
haven't been thinking. I can't think of, I think dermatology, something in that field has always been something I've wanted to do, but I'm not quite sure yet.
So, but maybe something in medical, maybe something in
Yeah.
science,
Yeah.
and have you looked into like what it takes to go to medical school?
Like the years and all that.
No, just like the degrees that get you there, because there's actually you could go into almost any science degree and get into medical school.
Oh, wow.
Yeah, I mean, like what you probably don't want to do is go into engineering because that's really hard.
Yes,
but
no.
but you know, but obviously if you can get through it and get a good GPA and all that, but a lot of medical students start out in chemistry, biology, other science programs too. It just depends what, you know, you're looking for. Sometimes it's easier if you know like the medical school you want to go to, because then you know, okay, I need this degree and this degree is available at this university, and you know, work backwards. Anyway, let's jump into number 38. And the system here is it appears like, maybe there's no solution to this, but you normally use substitution, and I still want you to do that. So I want us to solve both for y. There is another way to do this, but let's just keep it consistent. Let's solve both of these for y. So in the top equation, you're going to add 2x squared to both sides. And on the second equation, you have to do the same thing. We're going to tackle the first one. So it's y equals 2x squared plus 14x plus 16. Okay. In the second equation, yeah, we're going to add 2x squared to both sides, but it becomes, and I'm going to do it over here to the right, becomes minus y equals 2x squared minus 14x minus 12. But we got to solve it for y, not negative y. So you want to change the sign of each of these. So it becomes minus 2x squared plus 14x plus 12. And since they're both solved for y, okay, you can set them equal.
Yeah.
And that's key. Okay, so it's 2x squared plus 14x plus 16 equals minus 2x squared plus 14x plus 12. And whenever you're solving a quadratic, you want to get everything on one side of the equation. You want to get 0 on the right-hand side typically. So you're going to add 2x squared. You're going to subtract 14x, which they're going to cancel, and you're going to subtract 12. Basically, this problem here is to see if you can keep track of signs, because you're going to see here it's not that difficult when you get down to this equation. But if you don't keep track of your signs, you'll get something much more complicated. And you should always ask yourself that. You should always think, you know, is the question, is the instructor trying to give me a really complicated answer? Like, is that their style? Just to sort of know if you're on the right track or not. Okay. So again, you can use the greatest common factor approach here. You can factor out a 4. Okay. And then you set each term equal to 0. Now a term must have an x. Must have an x. So 4 is not a term, but x squared plus 1 is. So if you're still with me here, you subtract 1 from both sides. So x equals plus or minus the square root of negative 1. This is no solution.
Yeah.
and maybe it's frustrating. Okay, we did all that work to get no solution. Maybe we could have seen that from the beginning. Yes, we could have, but your path here for doing problems like 37 and 38 is you want to substitute, you want to solve for y or solve both for y and really work them out the way we just did. That's you're going to work 80% of the time for you on these tests.
Yes.
Okay, so once you figure out there's no solution, you're done. You don't have to substitute back in for y. There's literally no solution, so you're done. There's nothing more to say. And I think as a student, sometimes you're like, wait, isn't there more to do? There is no more to do. You're completely done.
Yeah.
Okay, can we move on to 39?
Yes.
All right. All right, so it says to graph this. So a couple things. You really want to do it without the inequality. You want to be able to graph y equals x squared plus 3. And it helps if you have kind of a general idea of what to do. I remember maybe our first lesson was on some graphing stuff and we did some tables. But what is the transformation of this graph? What is the only transformation? What does this plus 3 do if you remember?
Oh, it goes up.
It goes up 3, yeah. So your standard parabola starts at the origin. Maybe we will make a table. Your standard parabola is the following points. And I'm sure you've seen this before. So I'm just going to graph them here. Oops, that's wrong. Okay, so that's your standard parabola. Okay, but the one we want is going up 3. So we need to literally move every point up 3. Okay, so you can either do that in the table or you can just do it on the graph. Which do you think you would do? Would you do it on the graph or in the table?
Sorry, say that again.
Would you do it on the graph or would you go to the table and make new data points, moving it up 3?
On the graph, probably.
Okay, I think yeah, I kind of agree with you on that. So I'm going to do that in a different color here. Let me grab, I don't know, we use red. I know red's a bad color, but we'll just do that. So every point I'm moving up 3. Okay. Now this inequality, is this a solid or a dashed line?
Oh, I always mix these up.
Okay, well, I don't want you to miss it. It's solid because it's greater than or equal to, less than or
I
equal
was
to,
gonna say solid, yeah.
and then dashed are the ones without. And so, yeah, you do want to connect them. Okay. And so there's 2 correct answers now. You're either shading inside. Oops. You're either shading inside. I guess you can't see that with my cursor. I don't know why my cursor isn't showing up. Yeah, you're either shading inside or on the outside. Do you know how to do that based on this, or did you talk about testing points in class?
Yeah, we talked about like testing 0.
So you can test 0, 0 as long as it's not on the line.
What do you mean by that?
Well, you don't want to test a point. You would not want to test 0, 3 because it's on the curve.
Oh yeah.
But 0, 0 is a good one to test. Okay. Now what you're doing is you're building a truth statement. And you're really asking this question. So let's test 0, 0. And you're asking this question, is 0 less than or equal to 0 squared plus 3? You're basically asking, is this true or is this false? And what say you? Is 0 less than or equal to 0 squared plus 3? Is that true or is that false?
It's true.
It is true. So you shade the true region.
And then if it's false, do you shade inside?
You shade the other one, yes. This only works when there's 2 regions. And there are only 2 regions in this problem. That's why we can do it this way.
Yeah.
You can also do this on your calculator. We can cover that if we got some time at the end. If you think that would help. That's why I asked, because I would actually think you wouldn't get the calculator on this, because it really helps to make this a lot easier, faster. But I'm not in charge of
Yeah.
your test, so
Yeah.
maybe it will be there. All right. So this one, and I guess I'd see, the problem is I don't know how you're going to know how to decide how to graph this, but one way is to use formulas for the vertex minus b over 2a. Did you see that in class?
Yes.
Okay. When it's in what's called a standard form. Okay.
I actually, sorry to interrupt, but I just remembered that he gave us the problem that's going to be on the quiz. That's like the one that says graph the inequality. And I have
Oh, yeah. Do you want to send it over, or can you tell me it for,
yeah, I can tell you because I have it on my phone, a picture of it.
okay.
So it's y is less than x squared minus 6x plus 5.
Okay. So this is great because it's the same style of problem. We want to find the vertex minus b over 2a. So a, b, and c, they're the coefficients. What is the value of a in this equation?
It would be 1.
Be 1, b is minus 6, and c is
5.
5. So, oops, screen just froze up. So minus b minus a minus 6 over 2 times 1, 6 over 2 is 3. But we need the y value. Like, that's not good enough to just get the x value. You get the y value by taking the x value and putting it back in to the original equation. So it's like y equals 3 squared minus 6 times 3 plus 5. So that's 9 minus 18 plus 5. That's negative 4. So the reason we did all that, and that goes back to our very first lesson, is that vertex is the central point in your table. And then you pick 2 smaller and 2 larger. And yes, there's other ways to do it, but we'll just go with this approach for the moment. Do you want to try 2 or 4 in this equation?
We can do 2.
Okay, I want you to try that on your own, please. You're just putting it back in, 2 squared minus 6 times 2 plus 5. Give me that answer whenever you've got it, please.
Okay. I got negative 3.
Yes, that's correct. Okay, so what's nice is by symmetry, 4 is also minus 3. Okay, so if you could try either 1 or 5, and let me know what you come up with.
Did you say try 5?
Or 1, either one.
Okay.
Either one, they'll give you the same answer.
I got 0.
Yes. Okay, so now you're going to graph these 5 points. And does your instructor usually give you a graph, or do you have to make it up on your own?
He usually gives us a graph.
Okay. So just get it as best you can on here, but this is very important. So once you get the points, you got to go back and decide, is it solid or is it dashed? It's based on the less than. And that is a dashed line. So just make sure it's not, it should be very clear to your instructor which one it is, dashed or solid. Try to be very, very clear with that.
Yeah.
You don't get any points for deception as a student.
Yeah.
So now you got to figure out, okay, which side do I shade? You can test 0, 0 again. And you're again, you're just asking the question. You're asking, let me go ahead and rewrite it here. Is 0 less than 0 squared minus 6 times 0 plus 5? Is this true? And it should be very clear. It should never be an uncertainty about it. Is this true?
No. Yes,
No.
it is. Yes.
Is 0 less than 5? Yes, it is. Okay, so it is true. And you shade the true region. You don't have to overdo it with the shading. You just have to be very clear what you're shading.
Okay. I think I also have, maybe if we have time, one more. I know I have, because he can kind of gave us like little.
Yeah, that's fine. If we do whatever you want to work on. Yeah, if you want to give it to me, the question verbally, that's fine. Or if it's easier, you can send it over by email.
Yeah, let me find it real quick. Okay, so it's like a base times height kind of thing. It says solve for x. The area of the triangle is 27 inches squared.
At 27 inches squared.
Yeah, and then it shows like a triangle, and then it's split down that like corner, yeah, right there. And then in the middle of the big one, it says x minus 3.
For the height.
Yes.
Okay, and does it give you the width?
It says x.
For the width?
Yeah.
Okay.
And then it says, and then it gives an equation, it says a equals 1/2 base height.
Yeah, and you had we had talked about number 10 missing the area on your
Yeah.
view, and this looks like exactly like number 10. Let me grab that. Yeah, so you need the area of a triangle because you know the area is 27, and the area is 1/2 the base times the height. So what is area? A is 27. Great, hooray. The base is x. The height is x minus 3. Is that okay so far? Like all I've done is literally sub in for B,
Yeah.
for H, and for A. Okay.
Yeah, that's perfect.
Now, my preference, and I think this is something I would tell every student in the classroom, is to eliminate fractions immediately. There's like nothing good that comes from fractions, almost never. And to do that, you multiply by 2 on both sides of the equation. Now, what I think is unclear is that you're only multiplying the fraction by 2. This is all one term. Okay, which means that you don't get to multiply each of them. You multiply one term, you multiply the 1/2. So it becomes 54 equals x times x minus 3. Is that okay? Is that clear?
Yeah.
Okay. Because it could really, it really turns the problems if this isn't it. So now on the right, you're going to distribute the x to both. So you get x squared minus 3x. And then we've talked this over and over again. You really want to get everything on one side of the equation. Now you could say, oh, I'm going to move everything left, but then it becomes negative x squared, positive 3x. So instead of doing that, just move the equal sign to the right. Like once you're at this step here, I can't really do it, but equals 0. It becomes equal 0. And now it looks the way you want.
Yeah.
Okay, so now our options for solving, our first option is to factor. And it's really nice when we can use GCF, but this one doesn't have an X and everything, so we can't use GCF, that's out. This is what's called an A equals 1 type. It's where you're finding two numbers that multiply to -54 but add up to -3. So can you think of two numbers that multiply to -54 but add up to -3?
Yeah, so it's gonna be 9 and 6, but I need to think of which ones are negative.
So you write them both is my recommendation, and then one of them will stand out as being more negative than the other.
It'll be -9 and 6.
Yes, so x minus 9, x plus 6, but don't lose sight of like what you're doing. Don't lose sight of, okay, is this the answer? No, it is not the answer. You have to solve each of them, set them each equal to 0. So x equals 9 and x equals -6. But this is where I think, there's a lot of frustration with math. These are not both the answer. Let's go back to the problem here. What does x represent physically? And this triangle, a width. And we know a width cannot be negative. So even though, and we can talk about why this is true, even though x equals -6 is a solution, it is not the solution to this problem.
Yeah.
But x equals 9 is. If you took geometry, which I think you have, you said you've taken geometry?
Yes.
So in geometry, there's a number of problems where you would solve for x, but also like find the width and the height. And since we don't know, I know this one says to solve for x, the problem of the test may be determine the base and the height. You may have to put that x value back into the equation. Does that make sense? Like you may not be done when you think you're done.
Yeah.
Okay.
Okay, and then
so that's it. That's our answer. X is 9.
yeah.
Yep. Okay, we got a few minutes left here. So there's anything else you'd like us to cover today?
Yeah, I can try and find one more problem because I have pictures of some stuff that I took.
Sounds good.
Maybe one of the ones where it's like you must express your answer in standard form and like simplify each expression.
Do you have an example of one that we can?
Yeah, I actually do.
Okay.
So it's parentheses 7 plus 2i.
Oh, okay. Yeah.
Yeah, and then -3 or parentheses 3 minus 4i. I just need to refresh my memory because I'm like forgetting how to do things.
Yeah. So the most important thing here is that you distribute the negative first. So it's -3 plus 4i. This is your SAT style question where you have to remember to do it to both.
Yeah.
Okay, and now when it says standard form, it just means like you have to put the real part first and then the imaginary part second. So you combine 7 and -3. Which is 4.
Yeah.
And then 2i and 4i makes 6i. And so this is correct. And this is wrong.
Right.
Which I laugh at. I mean, I don't know. I mean, to me, I guess it's like the equivalent of wearing your shirt inside out or something. I don't understand, but I mean, I think that's wrong, but I don't know why this is.
Exactly.
But shirts, you have a standard form, right?
Yeah.
Unless styles have changed. I don't think they have though. All right, well, I guess we'll get another chance on Sunday to work through some stuff. It would be good if you had like a list of questions to work through, or types or ones like, hey, can you give me another one like number, 6 on the practice exam, or can you give me another one like, 24? Or I can just make them up too. But if you have some, or the ones you think will be on there, we can just work on those.
Yes, that's perfect.
All right. Well, that's probably it for tonight. I thank you again for scheduling, and I'll send you the notes here shortly, and I'll see you on Sunday.
All right, see you on Sunday. Thank you.
Have a great night. Bye now.
Bye.